Our last examples of graphing are going to look a little bit more complicated. They're not as scary as they look, though. All right, there's my advanced warning. Example 3A here. We're going to combine transformations. So example 2 there, you saw a reflection and either stretch or compression, but now let's throw in some of those translations too that we were graphing. Let's graph a parabola again here. Let's graph f of x equals negative x plus 1 squared minus 3. Whoa, there's a lot of stuff going on here. And just like before we start graphing, let's think about what are these transformations that have happened. I see I have this negative here outside. I have this plus 1 inside our parentheses. I have this minus 3 outside. Well, let's go through. Let's just go down the line. This negative, it's on the outside, which means it's going to affect our graph vertically. Well, negatives reflect, so it's going to reflect over the x-axis. Okay, this plus 1 inside the parentheses, it's inside, which is going to affect our graph horizontally. And everything on the inside is the opposite of what we think. So that plus 1 is really going to go left 1. This minus 3, it's on the outside, which is vertical. That's good. And vertical does what we think. So this is going to translate down 3. Well, let's make our table of our parent function first, and then we'll think about how are we going to do this? How are we going to change our values? I have this exponent here. So that means my parent function is y equals x squared. So x squared, x squared. Okay, looking at my problem, again, I have 3 transformations here. What one am I supposed to do first? Doesn't matter? Okay, it does matter. The order that we do our transformations is just like our order of operations. We would start off with our parentheses, exponents, multiplication, division, addition, and subtraction. So in our parentheses, we have this left 1. Left and right affects our x values. And if we're moving our graph left 1, our x values should get 1 smaller. So subtract 1 from each x value. Okay, and I'm just gonna I'll use a different color here. Put a check mark next to the left one to say, hey, we already did that one. Okay, next transformation, or next step in our order of operations, we did our parentheses. That exponent right here is just telling us what our parent function is. We don't have to do anything there. Then we multiply and divide. That's our negative right here. Reflect over the x-axis. Affects our y values. Make these guys all negative. And then finally, translate down 3. Subtract 3 from all of our y values. Negative 4 minus 3 is negative 7. Negative 4. And there we are. So this case, it really does matter which one we do first, which transformation. Because if we reflect and then move down, it's going to be a lot different than if we went down first and then we reflected, then we flipped up. So big difference here. Let's plot our points. We have -3, -7, -2, -4, -1, -3, 0, -4, and 1, -7. So as you can see in this one, even with all of our transformations, we can still see where the vertex is of our parabola. It's one of the nice things about doing your transformations this way. We always can see where our vertex is.